Hello students, in our previous session we had learned some concept of pair of linear equation in two variables. That is revised, when a pair of linear equations are represented on a graph, there can be three possibilities. We had discussed the first possibility, the two lines intersect in exactly one point. Today we shall discuss the second possibility and the third possibility. Second possibility is the two lines will not intersect however far they be extended, that is, they run parallel to each other. And the third possibility is the two lines are coincident lines, that is, they combine into a single straight line. Once again, recall the first one. For that we had taken two equations. We had found values of x and y for both equations. Then we had plot the graph for both the equations, and we observed that the two lines, they intersect at only one point. Whenever two lines are intersected at only one point, it is the only solution for those two pair of linear equations. And we had concluded that when a1 by a2 is not equal to b1 by b2, the two lines they intersect at a point. Today we shall continue our discussion. We will take up the second case. The two lines will not intersect however far they be extended. That is, the two lines are parallel to each other. To understand this particular statement, I have brought two equations, say 3x plus 2y equal to 18 and 3x plus 2y equal to 12. To plot the graph of these two equations, I have to simplify for the value of y. I have taken the first equation. The value of y is 18 minus 3x by 2. Let us take the tabular column. Let's make the tabular column. By taking the different value of x, I'll find out the value of y. I know for plotting a line, I require at least 2 points. So if 2 points are there, I can draw a line and find the value of y for two different values of x. When the value of x is 2, the value of y comes out to be 6, and the value of x is 4, the value of y comes out to be 3. We'll follow the same method for the second equation also. Value of y is written as 12 minus 3x upon 2. Let's make the tabular column. When the value of x is taken 2, the value of y becomes 3. The value of x is 4, the value of y becomes 0. Now with these two equations and these two tabular columns, I have to plot the graph. We get two lines. Let's do that. I have taken the graph sheet. On the graph sheet, I need to represent the equation 3x plus 2y equals 18. And we had this tabular column which was having the value of x and y. Now the x, y coordinates are to be mentioned on the graph. The first set of coordinates is 2, 6, and the second set of coordinates is 4, 3. These are the 2 points. Now I have to draw a line passing through these 2 points. We have to continue the same for the equation. Once the graph of the line is drawn, we need to mention that line is for which equation. So I have mentioned here 3x plus 2y equal to 8. Let's take up the second equation. 3x plus 2y equal to 12. The value of x and y were 2, 3 and 4, 0. Here we have 2, 3 and 4, 0. Now I will draw another line which passes through these two coordinates. Yes, you observe these two lines, they are running parallel to each other. They will not meet each other, however far they are extended. So what do we observe? What are our observations? We had these two equations, 3x plus 2y equal to 18 and 3x plus 2y equal to 12. If you find the ratio of a1 by a2, it is 3 upon 3. b1 by b2 is 2 upon 2. c1 by c2 is 18 upon 12. You observe the ratio of the coefficients a1 by a2 will be equal to b1 by b2 and it is not equal to c1 by c2. These are our observations. So what can we conclude? Conclusion is, for the two linear equations a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, the lines will be parallel if a1 by a2 equal to b1 by b2, that is not equal to c1 by c2. Now we shall take up the third case. The two lines are coincident lines, that is, they combine into single straight line. For that, let us draw the graph for the linear equations 5x plus 3y minus 15 equal to 0 and 5x plus 6y minus 30 equal to 0. Let us take the first equation. Find the value of y in terms of x. It will be 15 minus 5x upon 3. Let's make tabular column. I'll take two different values of x and find out the value of y. When the value of x is 0, the value of y becomes 5. When the value of x is 3, the value of y becomes 0. Let's take the second equation, 10x plus 6y minus 30 into 0. From this equation, y is 30 minus 10x upon 6. For simplification, let me consider the same values of x. The values of y will also be same. For this type of equations, in this type of pair of equations are there, we have the same values of x and y. Let us plot the graph for these two lines. So once again I have taken the graph. The first equation was 5x plus 3y minus 15 into 0. We had found x and y coordinates 0, 5, 3, 0. Plot the graph of 0, 5. Plot 3, 0. Now we should have a line passing through these coordinates. This is the line. The next equation was 10x plus 6y minus 30 into 0. We had the same tabular column. Now these two coordinates 0, 5 and 3, 0, they are at the same place where the previous coordinates were there. Now we have to have one more line passing through this. We can observe both the lines, the line which is there in brown color as well as the line which is there in purple color, they coincide. In such cases, we will not be having a unique solution, we will be having infinite number of solutions. Let's write our observations. These were the two equations. What is the ratio of A1 by A2? It is 5 upon 10. The ratio of B1 by B2 is 3 upon 6. And the ratio of C1 by C2 is minus 15 upon minus 30. On simplification, we will observe that all the three ratios, they are 1 by 2, 1 is to 2. So we observe that A1 by A2 is equal to B1 by B2, which is equal to C1 by C2. So what we can conclude? Conclusion is, for the two linear equations A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0, the lines are coincident if A1 by A2 equal to B1 by B2, that is equal to C1 by C2. Let us make a summary of what we had learnt and what we have understood. We have got a tabular column here. The first column is pair of lines, the second is algebraic condition, the third is graphical representation, and the fourth is interpretation. In the first column, I had mentioned the two linear equations in two variables. In algebraic condition, look at the first one, A1 upon A2 not equal to B1 upon B2. When we have this type of algebraic condition for the given pair of linear equations, on plotting graph, we'll get intersecting lines. The interpretation is exactly one solution will exist. That means there will be an unique solution. Look at the second condition, A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. When this type of algebraic condition is there, we'll get a graph in which coincident lines are formed. The interpretation is they will have infinitely many number of solutions. Look at the third condition, A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. For such type of algebraic condition, we'll have a pair of parallel lines. When pair of parallel lines are there, there will not be any common solution. We'll make two important statements. The first statement is, a pair of linear equations in two variables which has a solution is called a consistent pair of linear equations. Look at the table once again. We have got exactly one solution in the first algebraic condition, infinitely many solutions in the second algebraic condition. In these two conditions, we have got at least one solution, common solution. So we can say that they are consistent pair. The pair of linear equations are consistent pair. Look at the third one, it has got no solution since the lines, they do not meet each other. This particular pair of equation is called as inconsistent pair. So the third one is inconsistent pair. With this basics, let us solve a question. I have taken a question. Which of the following pair of linear equations are consistent or inconsistent? Use the algebraic condition of comparing ratios A1 upon A2, B1 upon B2 and C1 upon C2. Look at the first pair of linear equation. We have 5x minus y equal to 7 and y minus x plus 1 equal to 0. This first equation I can write as 5x minus y minus 7 equal to 0. Let me compare now the ratios. What is a1 by a2? It is 5 upon 1. What is b1 by b2? It is minus 1 upon minus 1. c1 by c2 is minus 7 upon positive 1. When you look at this, we'll have a1 by a2 not equal to b1 by b2. So the pair of linear equations has a unique solution. Therefore, the equations are consistent. Let me mention it here. So the pair of linear equations has a unique solution and therefore the equations are consistent. Let's take up the second one. Let's find out the ratio a1 upon a2, which is 3 upon 3, b1 upon b2, which is 2 by 2, and c1 upon c2, which is minus 4 by positive 1. We observe that a1 upon a2 is equal to b1 upon b2, which is not equal to c1 upon c2. Therefore, the linear equations are inconsistent because the equations has no common solution. Let me write it here. So the linear equations are inconsistent. If you plot the graph of these two, the lines will run parallel to each other. Let me solve the third one. In the third, we have got equations 2x plus 3y equal to 6 and 4x plus 6y equal to 24. For understanding, I rewrite this equation as 2x plus 3y minus 6 equal to 0 and 4x plus 6y minus 24 equal to 0. Find out the ratio a1 upon a2 is 2 upon 4, that's 1 by 2. b1 upon b2 is 3 upon 6, same as 1 by 2. c1 upon c2 is minus 6 upon minus 24 is 1 by 4. You can observe here a1 upon a2 is equal to b1 upon b2, which is not equal to c1 upon c2. So the pair of linear equations are inconsistent. If you plot the graph of these two equations, we get two lines running parallel to each other. Let's take up the fourth equation. The equations are x plus 2y equal to 3, 2x plus 3y equal to 7. So what is a1 upon a2? 1 upon 2. What is b1 upon b2? We get 2 upon 3. What is c1 upon c2? Is minus 3 upon minus 7, same as 3 by 7. Compare only the first two, a1 upon a2 and b1 upon b2. They are not equal. Whenever a1 upon a2 is not equal to b1 upon b2, say that the pair of linear equations is consistent. Where they have a unique solution, we get intersecting lines. Let me take up one more question of the same category. Let me find out the ratio of a1 upon a2. a1 upon a2 is 3 upon 6, which is equal to 1 by 3. b1 upon b2 is 4 upon 8, which is equal to 1 by 2. c1 upon c2 is equal to 5 upon 10, 1 by 2. Look at the ratio. Each time we are getting 1 by 2. Therefore, it implies a1 upon a2 into b1 upon b2, which is equal to c1 upon c2. Whenever this type of algebraic condition is there, we say that the pair of linear equations is consistent. It is because we will have two lines which are like coincident lines. They will have an infinite number of solutions. Therefore, the pair of equations are consistent. We shall solve one more question before winding up the question. This is a question related to the graph. Question is, solve the following system of equations graphically. 2x minus y equals to 4x minus y is equal to 8. Also find the points where the lines meet the x-axis. To solve graphically, we require to plot the graph for these two linear equations. The first linear equation is 2x minus y is equal to 2. What will be y in terms of x? It will be 2 times of x minus 1. When we transpose 2x to the right hand side, it becomes minus 2x. When it is rearranged, it becomes 2 times of minus 1 by taking 2 as common. Let us make a tabular column. When the value of x is taken minus 1, the value of y is minus 4. When the value of x is taken as 0, the value of y is minus 2. Let us follow the same procedure for the second equation. 4x minus y is equal to 8. Y becomes 4 times of x minus 2. So the tabular column, if I take the value of x as 1, the value of y will be minus 4. And the value of x is 2, the value of y is 0. Let us plot these two equations. On the graph sheet, I require x-axis and y-axis. For that, I'll note down the equation. We have the coordinates -1 comma -4, 0 comma -2. I'll take x and y axis. Let us locate -1 comma -4. It's in the third quadrant. Let us locate 0 comma -2. It is on negative y axis. Let us draw a line passing through these 2 points. And here is a line. It's passing through these 2 points. Let's follow the same thing with the second question. 4x minus y is equal to 8. We had this tabular column, coordinates 1 comma -4, 2 comma 0. Plot time 1 comma -4 is there in fourth quadrant. 2 comma 0 is in the positive x-axis. Let us draw a line passing through these 2 coordinates. Now you can observe these 2 lines, they are meeting each other at a point. A, I have named it as A, 3 comma 4. In the question they had asked, also find the coordinates where the line cuts the x-axis. Here you can observe the first line meets x-axis, cuts x-axis at 1 comma 0. I have named it as B, point B, 1 comma 0. And the second line cuts the x-axis at 2 comma 0. Let me name this as point C. So let us write this separately. First thing is the unique solution is three comma 4. Second answer is the graph of the equations cuts x-axis at point B 1 comma 0 and point C 2 comma 0. Hope you have understood it. We will continue the next session with some more questions, and also we will find the algebraic method to find the solution of pair of linear